So let's revise again. Single pixel imaging is a novel computational imaging scheme. Only a single photo detector is used to acquire spatial information of targets and reconstruct the targeted scenes through computational means. Therefore, to obtain information of image, a large number of measurements are needed. Quite a lot of methods have been proposed to solve this reconstruction problem based on compressed sensing, which needed certain boundary sets and could be done in works published by other people. The major drawbacks for single pixel imaging compared to the normal conventional camera is they have lousy image quality and longer data acquisition and processing time. So what is deep neural network? Machine learning is a class of function interpolation algorithms that are informed by examples of the function being interpolated. From here, neural network is being introduced. It is a multi-layered computational geometry composing elements on each layer where the elements are simple non-linear processing units. Each unit receives its input from the previous layer as weighted sums. The exception for this logic is the first layer in the neural network, where the inputs of the first layer are the measurements we wish the neural network to process. Recent work shows that architectures with more than 3 layers are demonstrated frequently. Therefore, as there are more layers, we will call it deep neural network. The optimization routine is done by implementing the process of adjusting the connection weights. The difference between the desired DNN output and actual DNN output training loss function is minimized to adjust the weights in the supervised training mode. In traditional CI, for each imaging operation, the optimization routine must be computed, whereas in deep neural network, the optimization routine is required to execute only during the training phase. This in turn speeds up the process of computation through applying deep neural network, as trained DNN is a feed-forward computational architecture. Therefore, instead of iterative computation methods used by traditional CS recovery methods, there is a huge possibility for a trained deep neural network to speed up the computational process to another new level. As what I have said just now, CNN networks were used to reduce an image into something easier to comprehend, but the case is different for compressed sensing recovery problems. In CS recovery, images are the result output, while inputs are in fact measurements obtained through various methods. A typical CNN network which simplify the image is therefore inapplicable. Reconnect tweaks the traditional CNN architecture, relinquishing the step to obtain initial measurement for the input. Instead, Reconnect directly map the image into different image blocks, as shown in the same figure, where when there is a scene, it is automatically divided into blocks, and after that, through the layers, the images with the block reconstruction will be mapped directly into the reconstruction. And this is the image comparison between the original image and the reconstructed image from Reconnect, and this is the image which are being gone through the disaster detection model. So what is single pixel imaging? Single pixel imaging samples a scene using only a single pixel detector and a series of mask patterns. Based on the sequence of the measurements taken while sampling the scene, the image is then reconstructed through their corresponding modulation patterns with the help of reconstruction algorithms, as shown in the image right, which is the image of a 1 pixel camera, where we capture the scene using a photodiode, which is the light detector, and we output the data from DMD array as bitstream and reconstruct as image using algorithms. It is more cost-effective compared to focal plane array technology, and it works well in non-visible wavelengths and low light conditions. SPI image reconstruction problems are solved mostly through iterative means, which they ran through and again to acquisite measurements.